optimization problem, the one we left off with yesterday. Why is it an optimization problem? Closest. And closest means, oh, it's right there. Yes. Minimum distance. And how do we do any sort of find a max or find a min? Find the max, find the min. Yeah, think of functions that we know with relative extrema, right? With relative extrema and or with absolute extrema, aka we need critical numbers and endpoints if there are endpoints. So, why do I have a circle leading from the beginning fact of my graph, y equals 4x squared, to a y that is present in a distance point? What have I not done yet that we need to do next? I mean, I could do the x squared. I'm not sure I want to square that yet, though. Why do I have a circle here and a circle there? And a little, oh, maybe you don't see it in here. Plug it in, plug it in. Is that minus 2? Yeah, because it's x minus 0, 1, and minus 2. Those of you guys are like, square it! No, come on, be smart. What should we do before squaring? Yeah, 4 minus 2 is 2. That'd be a lot easier. 2 minus x squared, squared, plus x squared. Alright, how do I do calculus? How do I figure out the minimum of this quantity, of this function? Okay. I don't know if I want to derive yet. Maybe I can. You want me to derive right now as is? Yeah, it depends on what you like better. Some of you might be like, forget it, I can take that derivative easy, and some of it for the u stuff. And some of you might be like, why don't you just FOIL it? It's up to you. Everybody have the most pronounced opinion as far as let's FOIL it first. I'm going to rewrite one more time. And we get, let's see, that's a plus 4. That's a minus 4x squared. And then an x to the 4th. But wait, I had another x squared. Why not just make that minus 3x squared? Does that work? 2 times 2 is 4. A minus 2 and a minus 2 is a minus 4x squared plus 1x squared is negative 3x squared. And 2 times 2 is 4. I think that's good, yeah? Okay. So then we take a derivative. So d prime is going to equal 1 over, well, forget it. We're going to be d prime, right, guys? Okay, so let's just say 2, bringing down the 1/2, making it a negative 1/2 to the power. X to the 4th minus 3x squared plus 4. And what's my u? 4x cubed minus 6x. What's my goal in taking a derivative? Critical numbers. And to find the critical numbers, why am I doing a pitchfork? Zeros at the top and bottom because I'm looking for both my zeros and my undefines, right? Okay. So zeros, how are you guys doing with x equals 0 and plus or minus, square root of 3 halves? Yeah. How did I get that?
Then becomes 2x squared minus 3.
And so if I'm setting that equal to 0, well, that equal to 0 is easy. That's just a 0, right? But that equal to 0 is 3 over 2 plus or minus square rooted of. Okay. Undefined. Bravo. Unless you start thinking about an x. What? You start thinking about multiplying to be 4 and adding to be negative 3. And you get a 4 and a... Oh, no, that doesn't work. Because if I was to get a negative 3, that should be a negative 4. Wait, but why was I doing a modified x anyway? Wasn't that a 4th degree polynomial? Why can't I? It's a trinomial, yeah. It's a u squared minus a 3u plus 4. because u could be x squared and u squared would be x to the fourth. It's a trinomial. So it was okay, except there's no way to make it work. So whenever there's not a way to make it work with factoring to get to nice zeros, how do we go looking for nasty zeros? Complete the square or quadratic formula. And I would say x squared, remember who my u is. X squared equals negative b plus or minus square root b squared minus 4ac. Oh, crap. Why am I going to be like, forget that? It's imaginary, which means, are there any zeros? Are there any undefines? Oh, okay, well, we went looking for them, but nope. So what's left for me to try? When x is 0 and x is plus or minus 3/2. Now, in context of the problem, could we start to visualize this just a little bit to try to figure out what's going on? Because 3/2, wouldn't that be hereish? The negative 3/2 hereish? Oh yeah, they're symmetric. And then couldn't we draw? Oh wait, that's. I don't know. Let's just look at it real hard and figure it out. Oh wait, 0. What's going to happen when we get past this point, though, to infinity, with the distance of the line? The distance is going to get greater and greater and greater and greater. We're looking for the minimum distance. And then, ooh, what's going on? Huh. What would you guys think of what we should do next? Okay, we could just plug in. This kind of looks like the nicest one to plug into, right? So we could just take our crit numbers and we could go ahead and say, all right, let's figure it out. And what Kevin's ultimately doing, I think, is just like basically one of those charts, yeah? We're trying to figure out for our different crit numbers, testing critical numbers and endpoints, what's going to happen. Now, I'm plugging into the distance formula, not the derivative, because I want to know what the actual distance is. If I plug in 0, 0, 0, square root of 4 is 2. Oh, wait, I already knew that point. Huh, okay, I wonder what happens at the other 2 points. Well, if I plug in, uh-oh, this gets a little rough. Oh, yeah. I don't know if I want to plug this one into that one. I have to do a 4th degree. I could plug it into that one, square root squared. That ends up being 3/2. 4/2 minus 3/2 is 1/2. 1/2 squared is 1/4. 1/4 plus 3/2. 1/4 plus 6/4. 7/4? Square rooted? Anyone double check me on that? But I'm plugging into this one. I guess I could have plugged into that one. That would have been this guy to the 4th power, which is square rooted that guy squared. So 9/4 minus 9/2 would be negative 9/4, and negative 9/4 plus 16/4 would be 7/4 square rooted. Which, yes, you could do is over 2 from this big. So why am I going to do the exact same thing here? Symmetry, right? So is that less than 2? How do you know that? Do you know the square root of 7/4?
The 7/4 is less than 2.
7/4 is less than, well, less than 2. It's also less than 4. And isn't 2 the square root of 4?
Yep.
Which would be the same thing as the square root of 16/4. Yeah, he's smaller. Right.
Maybe this is dumb, but for the quadratic formula part, isn't that not an imaginary number? Because b squared is 9, and then minus 4ac
It's minus 16.
What? Minus, oh, it's 4, never mind. Wait, oh yeah, it is.
But good catch though, because if we had been wrong, you're right. We should have used those
I think
numbers.
4 times 2. Thanks, Kevin.
So the lowest distance or the closest, could we say closest, least distance, is going to be at. Hold on, struggle. Didn't it say which points? What does that mean? You need the x and the y. So that'd be a square root of 3/2. I'm just being lazy and not not rationalizing. We just plug into the original function. Oh, didn't we do this a second ago? Oh no, we need the y. Wait a minute, I don't want the d. I can't plug in this guy. How do I find the y? Oh, that's right. Y equals 4 minus x squared. So this guy squared is going to be 3 halves. 8 halves minus 3 halves is 5 halves. Dun, 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 dun. Is there any other way to do this? What was the clue I gave you yesterday? The minimum d, the minimum square root of x minus x1 squared plus y minus y1 squared is going to be at the exact same place as where the squared is lowest 2. What does that mean? F is just the square of d, and if I could find the minimum of f instead of finding the minimum of d, well, that could make life a lot easier, because how am I going to find the minimum of f? Now, is it going to be very similar to the other guy? Yeah, it's going to need some similar work, too. But you would get to your critical numbers just a little bit easier. But do you guys realize you would still have to go through all the stuff that we did at the end anyway? All of this avoids is us having to do the quadratic formula, looking for the DNEs, and having to do a little chain rule with our derivative. So there is a shortcut, and technically you will always, with distance, the minimum of the square of d will always occur at the exact same place as the minimum of the distance itself. But if you don't remember, is it really a huge deal, or could you just do things the way you know how? Some of you still just freaked out because of the fractions and the square roots. It's okay. No. But this could have at least saved you the square root. Well, you still kind of got weird. I'm not sure if it really saves that much time, but it was a hint that I gave you. Could have just gotten to 0 plus or minus 3 halves by using the square of the distance and not having to think about this to the 1/2 power on top of everything else. We found it. It just took us a little bit of time. So what's that other guy that I had up here? Economics applications. Okay, hold on. You guys wrote down your homework problems, right? All right, so we have number 2. Number 2 is a geometry problem. Number 5 is a geometry problem. Number 9 is a, what do you guys think? Yep. Number 14 is a motion problem. Gotcha. Number 17 is a geometry problem. Number 23 is a profit problem. Okay, let's go check out number 23. Stop. Who's doing what and why? 23. Ooh, look at this fun little box thing. That's more exciting than last year's. What would that make if you folded and folded? Oh, it's like a rectangular one, but where you would glue those two together to make it like nice and strong and enforced, right? Because that would be a rectangle if you folded it up and then folded it up. That's okay, that's not it, that's not it, that's not it, that's not it. Quickest route. Jane is 2 miles offshore. That sounds like an AP problem. Anyway, sorry. They had a Jane who was, no, it wasn't Jane. Who was biking? Karen? With a C? They had a Karen with a C. And they had some J. Joy? I think it was Jane. Anyway, sorry, number 23. The poor little banana stalker guy never got a name. He was just the banana stalker guy. Yep, that's it. That's all we got. Who was the escalator guy? There was an escalator guy. Was that last year or the year before? I forgot what the escalator guy was. I think that was 2 years ago. So, what's the hint I just gave about profit? you think you might need that for this? Profit does equal revenue minus cost, because revenue is the money that comes. Nope.
It's the amount you made minus the cost of use.
Yeah, it's the money made minus the money spent. And then profit is the above and beyond. If you're literally poor, that's what you get out of it. Which revenue might already take into account some things. I wasn't thinking about that. Or just in general. Revenue is what's coming in, cost is what you're spending for whatever it is that you're doing. And profit is then the above and beyond. If there is above and beyond. If there's not, then you're in the hole. But what's going on with this? Suppose R of X, what do you think R is? Oh, hey, suppose R of X equals 8 squared root of X, that's revenue, and C, 2X squared is cost. Thousands of units. Ooh, you're selling by thousands. Is there a production level that maximizes profit? Whoa, they don't even tell us about, oh, come on. So what does profit equal? Who's P of X? R minus C. Yeah. So wouldn't it just be 8 squared root of X minus 2X squared? What's your job? Find the max. How? Derivative, critical numbers, go. What are my endpoints? Are there endpoints? Is there anything in here that tells me that the production is limited? I'm assuming greater than 0. Because if you're not making anything, you're not profiting. You're not losing. You're not profiting either. Okay. Take a derivative, find a critical number. Okay. That was number 23. What else is in homework? You guys have next number. I don't remember. 27. Guess what? Nope. Tour service. Maybe we should go back to that one. I remember that one being particularly fun. You're welcome. Number 41. Calculus and geometry has to do with distance between points. 45 has to do with vertical motion, objects on a spring. Physics people, you're welcome. Simple harmonic motion. Number 50 has to do with selling backpacks. Profit. Okay, number 27. Let's go look at the tour service. This is a serious you're welcome, by the way. Whether or not you realize it. Let me get rid of all this writing real fast. Oh, come on, computer. All right, let's see if or why this one is, why have all the kids that have used this BC book thus far not liked 27? I would say it's probably their least favorite of the entire optimization homework, and it doesn't even have geometry. No equation? What do you mean? Oh yeah, there are words. Exactly. So what is your objective? What do you have to do before you can even possibly start maximizing profit? Oh, so it really is profit. Yeah, but it's more interesting. We have time. You guys take like 2 or 3 or 4 minutes in your groups and see if you can figure out the equations. It's interesting. Ready, set, go. I won't even tell you what kind of equation it is. Oh. I'll see if you can figure it out. No, not parametric. Think it out. What are your clues? This is helping you for homework, I promise.
The rate of change is indicative to.
Okay. Oh, it's like the
I'm making you work on it because I have to remember it too.
Oh yeah, it should be 200p.
Victor, wrong.
He's trying to help.
That's what I thought.
Kevin, print the other one.
I'm turning towards victory against it. I don't know. I like so victory into this way. Okay. This is what I got. I don't know if I'm right.
Talk it out. You have to make sure that whatever someone comes up with perfectly models exactly what's going on. Plug in a few. Be like, what if it's this many people? What if it's that many people? Does it work?
As long as it's 50 people, so greater than 50.
Oh.
As long as, that sounds like a piece-wise function.
Second time. For each additional person, up to maximum.
I don't know, I heard as long as it's greater than, as long as.
200 minus 2 is 198.
After that, piece-wise.
That thing works. About yeah, like.
I got 6,000 plus 32 x.
Yeah.
Oh yeah.
I'm right.
Yes. I agree.
Oh,
200
you're right.
and
Minus. It's something minus.
Minus 50.
No. Right. So look at that. So that means minus 30. Wait, no. It's like that one person.
For each additional.
So max you can go down by it's 168.
Yeah. So it's 200 times x minus. Wait.
It's a fraction. Fraction. You feel like. No, it's not. Okay.
No,
200.
200 x minus 2x. Right?
So you'd have to be a decimal because
our prime
the price of
The rate.
all the rate. How much is it?
Yeah, so it's 200 x minus 2. Yeah, there's all.
I'm confused. Janelle, help us. Solve this. So, what? Yeah, I knew I was right. I knew it was a
Yeah.
No, that's never mind.
I mean, is it going to change? Yeah, 80 is going up.
Right. So you did 80 people, right?
Yeah.
Maybe
This is $40.
Maybe
If one person.
Yeah.
That's where they get you.
So
No,
every.
no. If you shoot it, they would have
Lot?
50 people.
Yeah, might be too lot.
So it's,
Yeah. But then you have to divide it
for
into
each additional person.
I haven't played it.
Oh, is this person? Oh, I think it starts at 50. I don't think they'll do anything with that.
I think that was great. I didn't know. I didn't really do all the thinking which made sense because it's also the end of the interval between the two and then a number, which means that it can be used so many times.
Yeah, okay.
But then, and I agree with the then R prime is just going to minus 2x.
Leaving after family.
Yeah, there is a difference. And then the cost.
Everyone come
I
back.
don't know if the second.
Yes.
Stop giving is like wording.
I think the answer is
What? You came there, Adrian.
I think that's what you're saying. What you were saying is like,
You came there,
the
Adrian.
more we have, the more money. I think you were wrong for sure.
that's not what happened.
It means financial crisis. No.
Can you read my piecewise function? Why is it x times? Isn't that the rate per? Right? The rate per. Well, what is the rate? Well, it starts at 200. Oh, but for every person you have over 50, you get to decrease $2 per person. So if you have 51, well, everybody gets to only pay $198. So you only have one of those $2 discounts. If you have 60, you get to, ooh, yay, now everybody gets $20 off. If you have 80, yay, I get $60 off per person. Do you see it?
Yes.
It's a little bit rough though, yeah. It's a little bit rough. But why am I able just to make this one 10,000? Because if you had 50 people, you just pay $10,000. It's no big deal. So you could do the 200 times 50 or just the 10,000. But then, well, it gets a little bit nasty, but I had to show you the idea first. But then we can make it a little bit nicer in that we can have something like, 200x minus, and then we have technically minus 2x squared plus 50x. I mean, we could actually have some fun with it that way. Oh, did I not make it 100? Oh, I'm sorry. So that'd be, let's see, we have our x times this and times the 2, and then 2x times x is 2x squared, and 2x times 50 is 100. Yeah. So I have my 10,000 for x equal to 50, and I have my 300x minus 2x squared. But if you guys just saw the 300x minus 2x squared and you were looking at CalcBC, it's an odd, would you have any idea where that came from? Probably not much. Oops, sorry, that's open interval. 50 is already accounted for up here. Why would that make any sense? Is this just one of those ridiculous that watermelon person has 55 watermelons in their car and you're like, this doesn't, I don't. Or could this actually have some sort of practical application as far as how this piecewise function is working? Why would you start saving money above 50?
Because the more people that come, you still make money off them, even though it's not as much as it was.
But you have to get past the fixed cost, right? And so you have to get past what? Because right now, if they bring in 50 people, that's 10,000, true? 10,000 of, we need to make at least $4,000. So they don't want fewer than 50 because like, it's not worth our time if we don't make at least. Well, hold on, wait a minute. No. What's the cost? It's not just $6,000. They have to pay $6,000 and then they have to pay per person, true? So then technically, if you were to plug in 50 would be a 0, 320, 320 times 5 would end up being 1,600? So 76, you would still only make like, 24. Anyway, they're like, okay, minimum we'll make 2,400 on this group, which seems pretty awful, but that's okay. Anyway. So they're like, okay, well, the more people that we bring in, they're paying a higher and higher rate. Sure, they're costing us $32, but guys, it's not near what the 6,000 is. You know what I mean? So adding a person here, adding a person there, if they're paying even like 160, 170, so they've done different math to figure out exactly what they want the discount to be, but it does make sense if it's just a fixed cost, and then, okay, per person, but yeah, the more people we bring in, the more money we make. Anyway. I think we have our cost. I think we have a piecewise of our profit. Sorry, of our revenue. So what do we need to do for profit? But Joe and Lorenzo, what were you talking about as far as the derivative stuff there? Because you were thinking ahead whether or not your function was right. What logic were you thinking as far as actually maximizing? And when you were doing that, you were saying instead of trying to find the zeros, what was the other way of thinking about it? Yeah, when R prime is going to equal C prime. Maybe you're going to be able to do it with by hand math because the function doesn't end up being that complicated. But if it was something where it was an AP calculator problem, you know there'd be decimals and all kinds of gross stuff or bigger degree polynomials. So it might be something where you want to find the derivatives of both, graph them, and find the intersections. What's my domain going to be? My endpoints? 50 and 80, right? So we're not gonna be looking below 50, not gonna be looking above 80. Could be due to the capacity of their vehicles or whatever. Or we would just look at a window 50 to 80, look for intersections, or you would look for when we're just looking at derivative. Maybe it might be easier on the window of your calculator to look for the zeros rather than to look for the intersections. Either way. I've helped far too much. This homework's going to be far too easy. Here you guys go. You have your homework problems. Few geometry ones, but I've done the worst one as far as I haven't done it. You kind of did, and I did it. But anyway, you guys have to finish number 20, whatever that was, 27?
Yeah.
But the rest you get to play with. Let me at least get up. For those of you guys that don't have a book and you can come over and take a picture of the book if you want. But we're putting up for you and freezing the screen on a page that will show you 2 and 5 and 9, and that's it. If you want 2 and 5 and 9. Do I have it? Yeah. I'll freeze the screen. You can come over and take pictures of my book. You can turn the pages because it's frozen. Everybody will still be able to see their 2 and 5 and 9. Whoa! There are paragraphs. You want us to write every word?
No.
Summarize the given information. Summarize the paragraph. And figure out what's the point and how do I get there given what I have. Does that make sense? Alright. Have fun, guys. If you guys spend the last 10 minutes of class being like, let me get done what I can. Come take pictures. It's okay. Oh, you guys only need 2 and 5 and 9, huh? I can zoom in. Hold on. Sorry. I can zoom in.
Area for
Not
There you go. 2 and 5 and 9. Here you go. Is that better? The screen is frozen. Come on down and grab pictures of my book if you want, but otherwise 2 and 5 and 9. There you go. Maximizing area, inscribing rectangles, and events. Events, fencing plan.
Oh.
David, here's your sentence.
It's due by the end of class. Alright, in general, a history essay about a current crisis in our. Oh yeah, but you can do some, but like, you wouldn't want to do someone who already has like a their life.
So you're taking a paragraph and just, like this one's going to be a little bit higher, so just shorten it.
No, but I'm
Thanks, David. Patricia.
okay,
Must have been absent.
wait, what?
Agent.
So, you know, for the
Corrections due Friday.
The
lowest
Specify.
So what happens?
Most
I'm typing.
yeah.